session on data science and machine learning for non-programmers. So before we start, let me quickly introduce myself. Myself, Krishna Prasad. I work as Director Consulting at CGI. I'm working there for the past 22 years, and I manage the big data and data analytics practice for CGI from Asia Pac. I'm recipient of the CGI Builder Award, which is given to one person across the globe every year. And I got the Sirius Award at India level. And I represent CGI in various forums. As part of that, I write various white papers, especially on the emerging technologies on big data and data science. And very active participant in the DCAL, which is hosted by IIMB and IISC. I am a solution architect and built various platforms, high performing data platforms for the leading banking firms, especially to the Wall Street firms. So that's where most of my passion on data and analytics come from. An alumni of ISB, I did my master's course there. So that's quickly about me. And let's quickly get into the core, what exactly you are getting into today and what exactly would be the way we will take this course further. So quickly, I'm getting into the agenda. So if you see the agenda, we will start with introduction of data science and machine learning. What exactly is data science? What is machine learning? And specifically, because we said this is for non-programmers, what exactly these two mean for you, and what exactly are the various roles that really make a data science team or a machine learning team. And we see quite a lot of terminology, jargons being used. So we will uncover some of the myths about how non-programmers can come onto the data science platforms. And specifically, we are going to focus on Python because that is one of the easy entrant. And given that there are a lot of easy libraries already available, we will try to go through the Python as an entry point into this journey. Now, quickly, what exactly are the various areas in Python we will cover? One is on statistical analytics, then what is the data visualization. So these two become the core of the entire data science or machine learning. And what exactly it means, I will cover. And then we go into the machine learning, deep learning, and NLP. So with the base of statistics and the data visualization, the machine learning and deep learning are built, and NLP is the advanced way on how we can achieve a lot of derivations from the machine learning. So that's how we look at the agenda today. Okay, so let's quickly get into the next slide on what exactly is data science and what exactly is the machine learning. So quickly, if you look into any of your organizations, wherever you're working, whether you are coming from a domain background, process background, technology background, one of the key things you will observe is you have enormous amount of data. The challenge today that the business is facing is not that they lack the actual data on which they need to take decisions. But what is the biggest challenge that the business is facing is what is the right way to get this data organized, to get this data massaged, and then make sure it is given to the business so that they can take the right decisions, or they can predict the right way so that management can take the right decisions based on the predictions. So that is the key challenge. So given the challenge, data science offers quite a lot of methodologies, processes as part of the umbrella of data science. So when we say data science, who are the various participants of the data science team? Data science is not meant only for technology people. It is only one part of it. So there are three elements. One is a domain specialist. one is a technology specialist, and third one is a process specialist. So we are going to focus more on the domain and process people who are trying to enter into data science domain today. The reason being, there is a misconception that we need to know a lot of coding if you are getting into the data science. So that is what we are going to show as we go slide by slide. You will understand how much of reusable assets and reusable code is already there. And it's very simple for you coming from non-technology background to understand the data science. And for that, one of the very simple thing I would say, even today, if you are not a programmer, you are already doing some sort of analytics, I would say, which is part of, again, data science. And very simply, I would say, if you are using Excel and using your VLOOKUPs on various formulas, pivots, that is exactly what is analytics, right? So we are taking away from Excel and putting into some structured programming language so that it can be used by better visualization and better management and interfaces that management dashboards use. So it is very structured way. That is the only difference we are seeing if you are coming from a non-technology background, which means you already have some base of technology that is required for a data scientist. Okay, then what is machine learning? So data scientists, in data science, there are quite a lot of algorithms. You will build models and you will do a lot of hypothesis and try to judge and give some reasoning around it. So when it comes to machine learning, it takes all those algorithms and then tries to make sure it creates an automated system, which means it could be a machine, and make sure it is automatically taking the decisions. So you start with data science, which where you take the data, you as data scientist create a model, and then give it to machine learning process, and that automatically will start taking decisions by itself, which means we are taking the human angle completely away. But there is a journey line even in machine learning where we start with supervised learning and then go all the way to the deep learning. So broadly, these are the two things in data science. One of the element called models or algorithms are used in your machine learning, and that is how the linkage between these two is going to be. So now, why we are going about in Python? What exactly is the reason we are only looking into Python? Because there are quite a lot of them, and there is a reason we cannot go across all the tools. We will go with the best and easily available tool in the market, and Python is one such thing. And if you go back and look at Python in 90s or 80s, at that time only Python is available, and they thought it's a very old code, and then it is dropped, and then we went into all the various other languages, and again Python came back when machine learning and data analytics came into picture. Why it came back? And this is the reason why it came back. It uses very, very less code. What it means is, to achieve your results, you need not really do too much of coding. With very simple 1, 2, 3 lines of code, you can achieve your target goal. Then it is platform independent. So if you go back and check, when you build your piece of code, you should be able to port into multiple platforms, right? And when I say platform, today you go and look into most of the newspaper items, you see every company is moving into cloud. You call one day Azure cloud, one day you say Microsoft, one day you say Azure, one day you say AWS, one day you say Google cloud. So there are multiple cloud platforms coming. So when you build a piece of code in Python, it can be easily portable to any of these platforms. So it's very easy. Then there is a massive community support. What it means is, because it's an open source community, there are a lot of members who are contributing to it, either they're using it or contributing, so that the leverage and reusable assets are growing. So that is where you see there is a massive community, and then there are a lot of pre-built libraries. We will see some of them today. So in majority of the open community kind of groups, it depends. If you have lot of members contributing to it, you will have lot of pre-built libraries, and that is what business want. Because if you don't want a limited set of members using it, then the challenge for you is, if you want to expand your teams, you don't get them in the market. Because Python have massive community, the business is also using more and more Python based platforms, because the community is vast. Obviously platform independent and less code. And lastly, this is where all of you will be more interested and impressed, is it's very easy to learn, especially if you're coming from a data science platform. Okay, so that is why we are restricting ourselves on Python, and there are quite a lot of other tools like R, RapidMiner, and others which we will using. They also come with quite a lot of pre-built libraries, but Python has overtaken over the last 10 years all the others. And the very good thing is, more than just the libraries, it has very good APIs and very good interfaces to the visualization and machine learning algorithms. That is the reason it has become more popular and is having a massive community. So I will jump into the libraries part of it. Yeah, the first we'll talk about Python libraries for statistical analysis. This is what we saw in the beginning. The first of the things where we said there are two base libraries. One is for statistical analysis, the other one is visualization. So let's start with statistical analysis. What kind of libraries are there, and how can we look at it? So NumPy, SkyPy, Pandas, and stats models. These are the four libraries that you have, or that help you to build your models in Python. So what is NumPy? As the name says, this is numeric Python. So what numeric Python does is, it gives you basic numerical support of all the functions and algorithms that you need to build with a very basic numerical algorithm. SkyPy is scientific Python. What it means is, it's built again on NumPy, but it has a lot of scientific and advanced functions out there. And Pandas is one of the latest editions, and this is what has really changed the way a lot of data scientists are using Python, because Pandas has become very, very useful and very, very simple. It's like you're writing your English, or you're just converting your Excel based functions into Python code. So it's so easy. That's where once Pandas came, of course, it's more used for data manipulation and analysis. That is the entry point for all the data scientists. And that is where Python has taken a huge leap by introduction of Pandas. And then stats models. This is, once you build the models, how do you do the analysis? How do you figure out what exactly is the hypothesis right? Is it working fine? What kind of result set or confidence percentages you are getting? All those things we will be seeing there. Okay, let's go each of them and then understand what exactly they are. So NumPy, as I said, this is built with a lot of scientific computations, which is, it will give a lot of functions that are required for numerical calculations. And each of these libraries, if you see, they have one basic element which is introduced. So NumPy is built on multi-dimensional array objects. What does an array means? Array means it will have elements in vertical and horizontal columns and rows, where you can apply your mathematical functions on that. Okay, so NumPy is built on multi-dimensional array, and you can apply all your data manipulation on that array. And then it is the base of statistics for ML algorithm. That's exactly I said. All these whatever algorithms you are building here, or all the scientific functions you are building here, forms the basis for the machine learning. Then let's go into SkyPy. Now, what SkyPy does is, it is again built on NumPy. NumPy forms the basic for SkyPy, but it brings in advanced mathematical computations. So let's look into, if you're, anyone of you are looking into the market scenario, the share market, you see the kind of algorithms, the graphs, the projections you need to do. So the kind of decisions you need to take in there is quite huge, right? You need a lot of mathematical functions and lot of micro and macroeconomic parameters. So that is where SkyPy is used when you want to take such high-end calculations and algorithms to be built, where the volume is high and the mathematical calculations are also not basic ones but high-end ones. That's where it says it provides a collection of sub packages, and each those sub packages combined together forms the large equation for you where you can take the decisions. And support for signal processing, this is exactly the reason why it's called scientific Python, because a lot of your signal processing, which needs a lot of linear algebraic functions, where you need to take a lot of decisions on a continuous basis. When you talk signal processing, it is real time, right? The entire decision should be real time, which means the speed of your underlying mathematical computation should be very fast. And that is the reason, if you are in such a kind of high-end kind of domain, you go into SkyPy. Now, next one is Pandas. As I said, Pandas is very relatively new. And earlier what we saw in the NumPy is based on the arrays, right? Here we use the data frame object. So what data frame object does is, it helps the developers, okay, to very easily manipulate and transform the data with very simple single line statements. And it's as simple as put a dot and say multiply A into B, and it will do the entire row multiplication and it will show you the value. So you need not really worry, okay, which column, which attribute, which row I am trying to multiply with which one on the data frame A to data frame B. That is not required. It's very simple, straightforward, right? And that is the reason I said, when it comes to Pandas, if you are doing a fresh start into the Python programming, this is the best place to start, because it gives you the entire flexibility and ease of learning. Okay, and time series, that is one of the very unique feature of this. It helps you, because once time series is given, especially when you are doing predictions, that is one of the core attention of the data analytics, right? So once time series is there, it's just you need to integrate your data to the time series data frame object, and it helps you in building quite a lot of algorithms out there. Okay, now what next? So you have seen the earlier three, NumPy, SkyPy, and Pandas. Now you build the models or you build the algorithms out there, but you need to test them. You need to understand what is the validation. Is it really working fine? What kind of test? You started with hypothesis, and then you need to test and say, okay, what is the confidence level of this algorithm? Because that's where you are going to your business or management and telling what is the validity of these algorithms you build. So stats model is something which will help you. And why we say supports R style formula here is because earlier R was very familiar, and all the users who are coming from R, or if there are some data scientists using R, it is very easy to integrate them also into this kind of a model. So that is the reason it used. So what it does is, it takes in all your algorithm, does the testing, validation, and then says how it is matching and what kind of confidence. Is it 80% matching, 90% matching with your ideal expectation of the hypothesis? Okay. So we spoke about the basic Python stat analysis, and then now we are getting into the visualization side. So what we saw earlier, what we saw is how will you build the algorithm, how will you build a model, and then how exactly we are testing it and seeing how exactly is it really matching your needs or not. But when you go and want to present it to your management, or when you want to give it to a third party user, you can't give the data in the form of numbers. Okay, the best way to give it to management or any other third party user is in a visualization format. So a picture talks million words, that's what they say, right? So if you put a simple picture, I think it shows very good impact, and then you can add some very top three observations do you have based on what your algorithm is predicting. So that is the reason the Python libraries for visualization are extremely important. And the good news is Python has very strong support of these kind of visualization libraries. And the very basic one and very popular one is the matplotlib. Now, matplotlib, as you can see, it is mainly for the plotting of the data which you have you derived from the previous algorithms. Now, this is a famous 2D plotting library, which means it has only 2D plots, and when you go into the very advanced ones, I think matplot has some certain limitations. The next one is it will extract the quantity. So what happens is it has very good interfaces where it can extract the info depending on the customizations you give, and immediately it will come with the customized kind of graphs which you want here. And it has variety of graphs available which will help you, and it is pretty old, which itself means it is very stable. However, because it's pretty old and there are not of other libraries came, the advanced graph features, advanced integration and API features, matplotlib cannot provide. So for that we need to go into Seaborn. So again, this is interesting. Seaborn is another library for again visualization side, and it is built with matplotlib as the base. So they took matplotlib as a base, and over that they built Seaborn. That's why it has if you understand, it's like inheritance, right? You took all the good features of matplotlib and then built the advanced features, and this comes with pretty strong visualization layer. Okay, and this is very attractive, and if you understand the term user experience and very attractive kind of graphs and models and estimation guidelines you want to give, this is the best thing. However, this is still a bit, I don't want to say it new, it is still evolving, so there will be certain challenges, but this is very, very good when you are getting into the continuous plotting like KDE. Okay, if you are trying to do KDE based kind of visualizations, this is the best kind of library you can use. Now, next is Plotly. It is again another thing which supports a variety of graphs. But the biggest advantage of this, as you can see, is you can build your public and private dashboards. And how you are able to do this is it is built for a web-based toolkit, which means your HTML UI screens which your application team is building. If you use Plotly, it is very easily exported to that, and it sits in as a API in it, which means you are building a very custom and very proprietary kind of UI which suits your need. Whereas in the previous ones, it requires a bit of more, it's not that it's not possible, but that is more concentrating on the models. So Plotly is more concentrating apart from the graphs, it also concentrates on how you can integrate and build your own public and private dashboards. And it, as I said, it has quite a lot of in-depth access to the graph. But one very good feature is inbuilt API for Plotly Grid. What it means is, if you have a graph, you can easily go into the underlying data. So data to graph, you can easily flip, which is one of the key asks for the visualization users at times. Otherwise, what you do is you need to go download your data separately and try to match when you are not really comfortable, whereas this provides that feature as well. Now, one thing I want all of you to understand, there is nothing called, okay, I'm not saying Plotly is good or Seaborn is good or Matplotlib is good. Depending on your need, depending on the kind of advanced features you need, the kind of complexity of graphs you need to pick and choose the library at the beginning of your data science journey. If you get into some, and how you do is you need to list, okay, I need feature A, graph A, I need these kind of interfaces, I need to show management user experience, or some of the ask might come from management. Once you list down all of them, you can see, you can take each of these of visualization tools and say, okay, this provides maximum number of features, and then you go with it. Now, everyone will have some limitations, each of these tools. The customization of the features which you are not able to achieve here is what your development team will be doing. So they are, the development team is, their main purpose is to do it. So don't try to solve the entire hunger of the world by taking one tool. Your core focus is making sure you build an algorithm, you get it the best visualization. There will be things which developers need to do, you can leave that job to them. Okay, then only you will pick the right tool. If you are trying to resolve all the issues, then you will get into challenges. Okay, now till now what we saw is, we are talking about, oh, we have data, we are giving graph. You have data, we are building a custom graph. Then we have data, we are building a high-end graph, and it has APIs and all that stuff. But what we did not talk, which most of us really like, is an interactive dashboards. Okay, and that is what Bokeh offers. This creates complex statistical graphs, but what it offers over and above just offering graphs is interactive, which means you can play around with it and get it into the better interactive mode in the way you want. And then it supports multiple language bindings, which is, I don't say it has quite a vast number of language bindings right now, but it's evolving. It's pretty new, but it's pretty much evolving. What are the other things like Altair and ggplot? They also are in the same thing like Bokeh, but Bokeh is really a leading right now. Okay, and integration with Flask and Django. Flask and Django are two frameworks in Python which are built for UI. It is like your HTML or Angular, React, which are built for your UI. In using Python, if you are asked to build a UI user interface, you can use either Flask or Django. So Bokeh has very strong integration with them, and that is the reason it has strong interactive based visualization. And transform visualization for other libraries, what it means is you can pick other libraries as base like Matplot or Seaborn, and actually it is built on both of them, so it takes both of their visualization and transform so that you can give the better interactive visualization here. Okay, so these are the top 4 which we have under the visualization side. Okay, so what we saw till now is how do you build the algorithm, which means you took some attributes and you built a model which you need to really use in one of the business scenario. And then whether that model, how exactly the results look like, we saw in the visualization. These two are the base. But when you really go and want to implement in an automated way, machine learning is the place where we are trying to see. There are very other lot of other places also where you can use your algorithms and models, but in this, for this purpose, we are restricting ourselves to machine learning. So as I said, what is machine learning? We build a model, we build an algorithm, and then we make sure the machine automatically takes the decision. Okay, and what it means is you start initially giving some inputs, and slowly what happens is the machine, you will give a feedback loop. What it, maybe let me put it this way so everyone can understand. Given the COVID situation, all of us are stuck at home. For sure, all of you would have attempted or seen attempting us to cook food, right? So when you start, either now or whenever you started, if you're really cooking food, the first day you will be thinking, okay, you'll be adding salt and then tasting, and then adding salt, again tasting, then you will add some spice, tasting, then you will add some other ingredients and tasting, which means you're unsure for this quantity what are the kind of ingredients you want to do. So you're doing slowly, adding some, tasting, adding some, which means it's a supervised learning. Either you are supervising or someone else is telling how to add. So that is how it will improve. So after third, fourth, fifth day, you will look at the quantity and say, okay, for this 1 spoon salt, if it is double the quantity, 2 spoons, which means as you go forward, you are mastering yourself and you know how it is operating. That is exactly what you are doing. As you go forward, as you get to know the attributes that are defining your algorithm, the machine will start understanding, okay, yesterday I got this much amount of rice, for that I added 1 spoon salt. Today you are giving double that amount, I will take 2 spoons. So it will derive once you put the feedback loop and does the calculation. That is exactly what is machine learning. I thought it's a very real life example so we can connect. Okay, but if you really look into your organizations, this is what we are talking about. Whether you talk about chatbots or you talk about Siri and other things, these are some of the examples where machine learnings will be used. Now, what do you have? Skykit Learn, then XGBoost and Elify. So let's go to the first one. Again, what is Skykit Learn? This is again the Python library. It's built on, when we saw, matplotlib, NumPy and SkyPy. So if you look at it, it is a combination of visualization as well as the algorithmic libraries you have learned in the past. So it combines all three and you have a common library which you want to use. And once you use this three, you are able to see using matplotlib how your underlying algorithm is working and how the decisions are taking, and you can provide or improvise the feedback loop as you go along. So the machine learning algorithms are nothing but the log algorithms which we learned in the previous two areas, which is your NumPy or SkyPy. It's the same thing, which if it is given in a way that you built a feedback loop, which the way I explained, it is called a machine learning algorithm. And it has a lot of inbuilt functions for feature extraction and selection. What it means is feature extraction. You want to select which features you want to really automate. Okay. And then what kind of data you want to select to make sure such a feature extraction can be done. And then once you do all of that, what you need to do at the end of the day is that model evaluation really working. Now, as I explained earlier, the Skykit Learn is built on Matplotlib and NumPy and SkyPy, which is very basic kind of either visualization or the algorithms you have. That is why it is more suited for supervised learning. So it is not meant for the unsupervised learning or deep learning. So that is about Skykit Learn. Then you have the second one, which is XGBoost. This is one of the, I would say, relatively new entrant in the market, but it is designed for high end and real time and fast and high volume kind of data. If you want to really take decisions based on large amounts of data, and quickly you want to take a decision and give feed the input, because understand machine learning, when you are in a super unsupervised learning, machine will take a decision on your behalf, right? So there is no correction mechanism. That's all post-mortem only. Later, if you think machine did a mistake, you need to come and fix it. And that is the reason it's extremely important in you give it enough data for it to build a right algorithm. And XGBoost is one such thing which helps you in very high fast data processing, which huge volume of data. And it is because it has parallel computation. It's built on Hadoop kind of platforms which are meant for this kind of high volume data processing and high accuracy. As I said, The moment you are bringing high volume and fast data processing, you cannot compromise on the results, right? Accuracy, your data output accuracy should be very, very good. And that is the reason XGBoost is becoming one of the very popular library right now. Okay, now just like how we saw in the past algorithms, here LE5, this again is to debug. So when you have built a machine learning algorithm, you want a way to debug and understand how much is the prediction right? So this is what we'll provide, and it is integrated to both Skykit as well as XGBoost. And you have even Lightning, another library. So this is the one which helps you in debugging. So if you look into any of the coding, I think someone said VBA. Even in VBA, when you write the code, unless you do debug, you don't know when you have an error, where exactly is the issue. Same is true here. When you have an issue in there, you need a debugger, and this will act as a debugger where it will explain you in real time. Once you run, it will say where exactly are the issues, where exactly you can better the model, and where exactly is it really not making more sense. So it is built for the better debugging, and it can fine tune your predictions well. That is the reason LE5 is used. Okay, so that brings us to the end of machine learning basic libraries. So now what is deep learning? We saw about algorithms and how exactly they are going to help us in various machine learning things. Now deep learning is about machine taking its own decisions, right? You are not trying to go and tell the machine, oh, this is the new input you got. Can you try to change the way you are looking at it? So which means you are literally replacing a human with a robot. And three of them which are very popular is TensorFlow, Keras, and PyTorch. And if you really look into it, this is nothing but most of it comes from neural networks, because it requires quite a lot of deep analysis and data that you need to mine to come to this one. If all of you would have seen the movie Robo, that's exactly is deep learning all about. You create one robo and it starts creating multiple robots based on its learning, right? So no one told the robo how a new robo can be created, but it by observing it could get into deep learning and started creating. And that is exactly is the scenario what we are talking here. A robo will create a robo and there is no human intervention required out there. So TensorFlow is one of it, where it can build and train multiple neural networks. And I would give one example of this. If you look at the bots today you want to minimize your costs. So where is your any company's major investment in operations? It is on the call center, right? There are a number of calls you take. It is some of them might be repetitive. So for repetitive kind of things, you don't want to really invest a human who can be used in much better high-end kind of task. So if you can replace and create an automated machine learning algorithm which can train itself based on the number of questions that are coming, and it can improve itself and provide better answers, that is exactly we are talking about deep learning. TensorFlow is one such kind of thing, where it creates a bot which can answer all kind of questions, basic questions that any customer have. And then if really it can't answer, it will pass it on to a operator. Then you will get a human touch. And this is exactly happens when you go into any of the sites. There is a pop-up where you see, okay, this is Eva, this is ABC, this is, they give a human name, but the one behind you are saying is a TensorFlow kind of machine learning algorithm, which is really answering you, but giving you a human touch and feel, because you don't really sense it's a robo which is operating behind. Okay, so TensorFlow, what exactly it does, this is again coming from, I think TensorFlow, yeah, it is from Google. It comes with quite a lot of statistic analysis, and you see in Google the kind of search and all that you do, it will come and give you what next best actions you can do and all. It's all coming from TensorFlow. And that is the kind of vastness you have on the deep learning. The next one is Keras. Keras is another kind of neural networks, again for machine learning. This is coming from Facebook, right? And the Keras is built on top of TensorFlow. If you look at it earlier, TensorFlow, I said it's coming from Google, but they introduced as a open source platform. Then Facebook on as a baseline of TensorFlow, they built Keras, and they used even CNTK and one more. I forgot. They used one more machine learning algorithm library. I forgot. That's okay. I think they grouped all three and came with much robust algorithm. That's what Facebook uses today, and comes with quite lot of. You don't really realize it, but if you go to Facebook, all this kind of video making and all these things you see, it is all being done by Keras in the background, because it tries to see, oh, who are your friends? Can I match them? Can I do a video for you both? Okay, what kind of proactive suggestions I can give you? All this is happening by Keras, and none of us as humans are going and say, this guy can be my friend, that guy can be my friend. It is doing some kind of algorithm behind the scene based on various other actions you do, and then it will suggest you what kind of friends, what kind of purchases, what kind of travels you can do. And that is exactly deep learning all about. Okay, now the next one is PyTorch, again coming from Facebook, and it is used by Twitter also right now. This is again another NLP, natural language processing, used for deep learning. So when I say natural language processing, it should be able to go and read the unstructured data, anything and everything, right? And it has very strong support base. The kind of operations and others that you have is very strong, and it is very widely used currently, PyTorch. Now, the last topic, Python libraries for NLP, the natural language processing. When you go into the deep learning, it's all about the NLP. And what natural language processing means is, let's take you have PDF, or you are getting a lot of unstructured data that is being thrown at you, or you have a lot of voice that is coming where you want to interpret the data voice and then take decisions. That is exactly what we are talking about here. So it could be your Alexa, your Siri, your what is that? This new Tesla automatic driving cars coming. These are all possible because you are able to build NLP, and that can take lot of inputs, lot of its algorithms based on the deep learning. Now, this is very advanced, and you will not be using this in your introduction of your data science journey, and these are used in a very advanced kind of scenarios. However, one scenario where you will use these kind of NLPs very frequently is if you are in the insurance or medicine domain, because you need to use a lot of PDFs and lot of medicine kind of data, which requires a lot of NLP. Okay. Now, one of the very easy thing which I can tell when you're talking about NLP is you go into web, right? When you go and see, there are a lot of comments that are coming when your new product is launched. There will be a lot of feedback that will be given by the users. It could be in English, it could be in local language, it could be. So if you want to understand what is the feedback of your product, you can't always go and say, okay, everyone is rating 1, 2, 3, 4. It's the qualitative comments. If you can read those comments and give a positive or negative number to it, then you can judge and say, okay, based on the comments, qualitative comments the users gave, it is still not a viable product, or we need to improve, make some improvements. And that is what, again, same is true with movies. If a movie comes, there'll be a lot of feedback, and based on that you will take a decision, okay, is it a hit or a flop? So that is exactly what we are talking about, natural language processing, where you read the data dynamically and then make some derivations out of it and then give the result set. It's all about, it could be text processing, it could be language converted text processing, it could be PDFs where you need to convert and then try to give some meaningful result out of it. Okay, And then, as I said earlier, there'll be a lot of local language and other things used. So Spacey is one thing which can provide you the lot of linguistics computation, which means, but again, there are certain languages which really you can't interpret dynamically, because one of the biggest issue we have is the negative connotation of certain languages. It's not really captured. So that is the area where there is a lot of R&D still going on. But given the limitations and we being this space being very globally exposed, it's very tough to come with a very accurate algorithm or model which supports all the kind of languages and kind of connotations, negative, positive, whatever people use. And the biggest challenge we have is there is a new language other than English, which is Gen Z English, where the entire words are misspelled, right? It's very tough to understand what exactly that means, because that's all slangs and whatever other things are coming. So that will be very challenging. So those are still being worked upon, but there are a lot of product companies like Google and all coming with some semantics which will help us, but it's a long way. This is just for your understanding. I'm saying I don't want you to get worried, oh, so much of it need to be learned. This is more on advanced analytics. When you go, you will be getting there. And then the last one, which is GenSim. This is more for how you do text processing to compare two different large texts, right? If you have version 1, version 2 kind of books, and you scan them and trying to compare, right? What are the differences and how exactly they are happening? Such kind of things. Where exactly are the gaps in your let's say there is a huge plant and you scan the entire thing and trying to see based on the original design to the scan you did on the plant, where exactly are the gaps. So such kind of things also you can do using GenSim kind of application. I'm just telling you, at the end we are saying I'm processing two documents. The underlying thing is I'm taking a blueprint before the plant implementation, and how the plant real implementation, I'm taking a picture of it and trying to compare these two to identify where are the gaps. So such is the power. Just imagine every pixel need to be captured, compared, and then given a real image, and then it will say whether it's really perfectly matching or not matching. Okay, so that is all I have on GenSim. Thank you all.